Welcome guys to an interesting video on waves and its types. In this video, we will understand what are waves, what are different types of waves, and at the end of the video, we'll understand why the phenomena of polarization is associated with only one type of wave. So, let's begin. So what are waves? Waves are traveling disturbances in a medium that carries energy without net movement of the particles. So basically what are waves? Waves are disturbances that are traveling and that carries energy with it, but there is no net movement of the particles. That means if a particle A is here at some time t, then this particle is the same particle is not be available at some other point at time T2, say T1 and T2. So it is the waves are basically the disturbances, traveling disturbances that carries energy without net movement of particles. This is what it means. And we need to remember that each succeeding particle of the medium performs a motion quite identical to its predecessor. So depending upon the motion of the neighboring particles, the other particles, each neighboring particle will continue the same motion. Now there are two types of waves, the longitudinal waves and the transverse waves. And what do we mean by longitudinal waves? Whenever we have longitudinal waves, the particles of the medium will move parallel to direction of motion of that wave, or we can say the movement is to and fro or back and forth. So whenever there is a longitudinal wave in a medium, suppose we have a longitudinal wave which is moving in this direction, then the particles of the medium, the surrounding particles will be moving parallel to this, and it is to and fro motion of the particles. So particles are just vibrating around their mean position. Particle is not getting significantly displaced to another new position. So this we need to understand the definition of wave, as it says that there is no net displacement of particle and it is the disturbance which is traveling that carries energy with it. So when it is longitudinal wave, when longitudinal waves are propagating in a medium, then the particles are moving parallel to the motion of the wave, and the particles are having very small or slight movement vibration around their mean position. It is to and fro or back and forth motion about their mean position. They are not permanently displaced. This we need to remember. So if we want to understand, suppose we have a spring which is hooked at one end and the other end is free. So other end which is free, we try to push and pull the spring. So what happens? Whatever disturbance occurs in this medium, that travels, but the particles, the air particles or air molecules, they are getting just slightly displaced, which results in formation of compactness of the air molecules, or say moving away of the air molecules, and this results in formation of compression or expansion in the wave. So this is what happens in a longitudinal wave. In a longitudinal wave, the wave disturbance propagates in one direction and the air molecule just move away from each other, so that results in formation of denser particles gathering in one region and particles moving away from each other in one region. That is what we call as compression and expansion for longitudinal waves. Now what are transverse waves? Transverse waves, whenever we have transverse wave, the particles of the medium move perpendicular to direction of motion, or we say the movement is up and down but perpendicular to direction of propagation of motion. Once again the same thing. Earlier we had, if the wave is traveling in this direction, particles were moving to and fro. Now we are saying the wave is moving in one direction, particles are moving up and down about their mean position, such that this up and down motion is perpendicular to the direction of propagation. So this is what happens in transverse wave. In transverse wave, if suppose the wave is moving in this direction, the particles around it will be moving up and down, just slight movement or vibration around their mean position. There is not or no permanent displacement of the particles. Now if we want to understand this with respect to a spring, say we have a spring and now once again it is fixed at one end and it is free at the other end. But now in this case, we are moving the spring up and down. So what happens? The wave travels this way, but the particles are moving perpendicular to this direction, resulting in formation of crest and trough. Whereas in transverse wave, we had formation of compression and rarefaction. So here it is crest and trough. Now we are all aware of sound waves. Sound waves, again, it requires a medium to propagate. Sound waves are, we also call sound waves as mechanical waves because they require medium to propagate. Here the medium is air medium. Okay, so now the sound wave is propagating in this direction. Propagation of sound is in this direction. Okay, so as the sound waves propagate, the air molecules or the motion of air molecules associated with sound results in formation of denser medium or denser gathering of the particles and rarer gathering of the particles. Some region we have more particles coming together, some region we have particles moving away from each other. So this is what we call as compression, where more particles are clubbed together, and rarefaction, where particles move away from each other. So where we have a compressed region, we say the pressure is increased. Where we have particles moving away from each other, there is decrease in pressure and it is rarefaction. So now we understand, as the wave propagates in this direction, resulting in formation of compression and rarefaction, this is an example of longitudinal waves. Light waves. Now light waves, as we know, are electromagnetic wave where electric field and magnetic field is moving perpendicular to each other. This is electric field or electric plane and this is magnetic plane. Both these planes are perpendicular to each other as well as perpendicular to the direction of propagation. So this here we can say that the particles are moving perpendicular to the direction of propagation. Hence, this is an example of transverse waves. One more interesting phenomena of light waves is that, see, this is what we have, the magnetic field and the electric field. Now this is one plane of electric field and one plane of magnetic field we have shown. But there are n number of planes, n number of electric field plane and magnetic field plane, such that they are all perpendicular to each other, as well as they are perpendicular to the direction of propagation. For simplicity, we always show one electrical field so that we understand it clearly. Now, moreover, when we are dealing with light waves, we are considering only electric field, not the magnetic field, because the strength of magnetic field is less. Now, suppose if we ignore the magnetic field and have only electrical field or the electric plane traveling along the direction of the wave, then there will be n number of planes, which results in a resultant look of this, where suppose if this is the direction of propagation of the electric field, that is in wave into the screen of the mobile, then we have n number of electric fields where these electric fields are perpendicular to direction of the wave. So this electric field is perpendicular to direction of this propagation of wave. So all these electric fields will be perpendicular to the direction of propagation of the wave. This is the resultant look what we can simplify and show instead of drawing this diagram all the time. If I had to draw the diagram, then I would have to draw this electrical field plane like this, many planes like this, n number of planes, right? So it would be a chaos to represent. So usually we show in this way. This do remind us of Sudarshan Chakra, where this is the direction of the wave, and each of this represents a electric field or a plane of electric field which is perpendicular to the direction of this wave, right? Now this is what we call as this same simplified picture, where we are considering the electric field to be vibrating in all possible direction as an unpolarized light. As an unpolarized light, right? Now, when we make this unpolarized light incident on a material which has got slits, fine slits in it, then what is getting transmitted is only the electric field which is having vibrations parallel to the slits, right? Rest all vibrations of electric field are stopped here, right? Then whatever is getting transmitted, we say the vibrations are restricted only in one direction, and this is how we get a polarized light, and this is known as polarization, right? Hope you have understood this. So polarization is a phenomena which is associated with transverse waves, because only in transverse waves particles are moving perpendicular to the direction of the propagation, while in longitudinal waves particles are moving parallel to the direction of the propagation of the wave. So here for light waves, because we have n number of electric fields or n number of electric field planes, we can restrict only one of the plane to vibrate in one direction, right? Which will give us a plain polarized light. We will have a light which will be having vibrations only in one direction or only in one single plane. This is what we understand by polarization. Hope you have understood what are waves. Waves are disturbances, traveling disturbances in a medium that carries energy with it, but there is no net movement of the particles. There are transverse waves and longitudinal waves. Longitudinal waves example is a sound wave. Transverse wave example is a light wave. Moreover, polarization is a phenomena associated only with transverse wave, because only in transverse wave we have the chances to make the vibration happen in one direction. I hope the concept is clear. To like, share and subscribe the channel for more such videos. Thank you.